This segment of the course will deal with choosing the correct propellant and hardware necessary to pour a perfect glass of draft beer. The more you learn about choosing and using the proper propellant and hardware for combining the right gases, the better the draft beer will pour and the closer the beer will taste to the product the brewer designed. In all cases, the real reason for using mixed gas is to help the bartender pour and serve the same beer the brewmaster brewed to the customer drinking the beer. We do this by making sure the gas content of the beer remains constant until the keg goes empty, no matter how long that takes. Why mixed gas? Dispensing systems need mixed gas for two reasons. First, when serving a nitrogenated beer such as Guinness, Pyramid Draft Pale Ale, or Old Speckled Hen. Second, when dispensing beers over the balance point, the balance point being the pressure above which 100% CO2 alone will overcarbonate the beer. All beers have carbon dioxide dissolved into them. Nitrogenated beer has nitrogen dissolved into it also. To properly serve nitrogenated beers, mixed gas must be used. Pure CO2 alone will allow the nitrogen to come out of solution. Pure nitrogen alone will allow the carbon dioxide to come out of solution. In either case, if using one without the other, the beer no longer looks or tastes like what the brewmaster brewed. The correct blend with these beers is usually dictated by the brewer, but in most cases it will be 25 to 30% carbon dioxide, the rest nitrogen. Guinness, for example, recommends 25% carbon dioxide, with the beer dispensed at 30 psi. Pressure may vary depending upon line run, line diameter, and height of line run called head pressure. Maintaining the correct blend and dispensing pressure is necessary to maintain the integrity of the beer. With most nitrogenated beers, a restricting or agitating faucet, often referred to as a Guinness or stout faucet, will greatly enhance the appearance of the nitrogenated beer. Systems requiring pressure set above the balance point due to viscosity of the beer, line distance, diameter, or head pressure require careful attention to setting that pressure. All beers, whether American domestic, such as Bud or Miller, or microbrewed, have a certain amount or volume of carbon dioxide dissolved in the beer. The carbonation is an ingredient chosen carefully by the brewmaster. In dispensing, it is our job to pick a blend that maintains this level of dissolved carbon dioxide. We set the dispensing pressure based on the bar's conditions, line run, etc., and choose a blend of CO2 to match. Nitrogen simply provides the extra pressure necessary to dispense the beer by moving it along through the lines to the faucet without overcarbonating it or allowing it to go flat. The correct blend keeps the beer at the correct carbonation level throughout the keg, no matter how long it is on tap. Mixed gas will, used correctly and properly designed system, keep the nitrogenated beer properly carbonated and nitrogenated. It will keep beers properly carbonated no matter how long they're on tap. It will prevent beers from going flat. It will prevent beers from going wild. And it will prevent wasted beer. And it does reduce foaming problems. Mixed gas will not give your beer the creamy head of Guinness. It will not fix beer that is already overcarbonated. And it will not eliminate all foaming due to poorly designed or maintained systems. Too much CO2 in the blend will cause a beer to pour wild and foamy because it will overcarbonate. It's just a matter of time. Too little CO2 in the blend will cause the beer to go flat. Guaranteed. It's just a matter of time. Choosing a propellant and hardware. First, I will list the choices of propellants and hardware. Then I will describe each one. Compressor. These are high pressure cylinders. Are bulk tanks. This is a blender. Here is a generator. This is a beer pump. And this is a fob. First, the air compressor. This is a mechanical device that takes air from the atmosphere, compresses and stores it under pressure in a tank to be discharged as a propellant. Even an oilless, beltless air compressor is an outdated method for a propellant due to contamination. These are high-pressure cylinders, available in varying sizes, and are placed in the proper location by your delivery driver. They can be connected with an automatic changeover valve. This allows for continuing supply when the cylinder empties. These are bulk tanks. Liquid bulk carbon dioxide is stored on the premises, preferably outside, in a stainless steel holding tank, and is refilled by your contracted gas supplier from a delivery truck. It is pumped in through a hose with leak-proof connections, similar to a fuel truck delivering heating oil to a household in colder climates. Here is a blender. This is a small piece of equipment, less than 1 square foot, mounted on the wall near or in the walk-in refrigerator where the beer is stored and tapped, and combines the nitrogen and carbon dioxide in the proper proportions. It is available for 1, 2, or 3 different blend percentages, depending on the beers chosen, and is preset by the manufacturer before ordering, not to be adjusted in the field. This is a nitrogen generator. A nitrogen generator is a compact machine that encompasses an air compressor, which feeds through either a filter or a sieve, and separates the nitrogen from the air. This captures the nitrogen from the air and is 99.8% pure or better, placing it in a holding tank in the generator. It is then connected to the system in conjunction with carbon dioxide from either a high-pressure cylinder or a bulk tank. Both gases are then run through the blender, combining the two gases in the correct proportions suggested by the brewer. This is a beer pump. The beer pump is designed to dispense any type of beer through long or short, vertical or horizontal line runs. This pump is driven by a propellant, and it allows the proper amount of pressure to be applied to the keg to ensure the correct internal pressure of the beer in the keg, while providing the correct pour rate at the faucet. Any propellant can be used. The beer and the gas, or the propellant, are totally separated. The drive gas never touches the product. It merely drives the pump. Therefore, a CO2 line must be connected to the keg to ensure proper carbonation level is maintained at all times. Changing the pumping pressure does not affect the carbonation level of the beer, since the driving pressure never touches the beer. This is a FOB. It stands for foam on beer. This handy device mounts on the wall of the walk-in inside, just above the kegs. When the keg empties, the FOB shuts off the flow of beer so that the line keeps packed with solid beer until the next keg is tapped. This prevents foam from coming through the system out of the faucet, thereby preventing loss of product and potential profit. The following are the choices of methods of combining and delivering gas to the kegs, and the advantages and disadvantages of each method. First, pre-mixed high-pressure cylinder of mixed gas, one cylinder, combination of carbon dioxide and nitrogen. Advantage, low initial cost. Disadvantage, least convenient, requiring the most frequent cylinder changes. Least adaptable, very few blends are available. Usually 25% carbon dioxide, the balance 75% being nitrogen. I often suggest this method to potential customers who are either low volume or trying a nitrogenated beer for the first time. Next, high pressure cylinders of nitrogen and carbon dioxide with a blender. Advantages, easy to find and set up, low initial cost. Disadvantage, you need a reliable supplier with scheduled routes in your area. Next, high pressure cylinders of nitrogen with bulk CO2 and blender. Advantage, economical source of CO2. Disadvantage, if leak occurs in the system, considerable volume of gas is lost. It is not effective for small to medium operations. Next, bulk nitrogen and CO2 with blender. It's rare. Advantages, very economical source of mixed gas. Disadvantage, bulk nitrogen not available in most areas. It is not cost effective for small or medium operations. And if a leak occurs in the system, considerable volume of gas is lost. Next, nitrogen generator with high pressure CO2 cylinder and blender. This is a popular method. Advantages, very economical source of nitrogen. It can be leased in some areas. Disadvantage, it is a high initial cost. Next, nitrogen generator with bulk CO2. Advantage, most economical source of nitrogen. Disadvantage, high initial cost, not cost effective for small to medium operations, and if a leak occurs in the system, considerable volume of gas is lost. In summary, choosing the proper dispensing system, propellant, beer selection, location of dispensing station, number of stations, number of lines or faucets, eye appeal of the hardware at the bar, and more, all come down to careful planning and contracting with an installer who has the experience and knowledge necessary. This is no different than hiring a qualified bartender or barista to dispense your drinks. Draft beer and post-mixed beverage are the best profit margin products in your restaurant. So choose a reliable supplier with a 24/7, 365 program. It's critical to keeping your beer flowing. So install, pour, serve, and profit.